We interrupt this broadcast with breaking news, fortunately good news. The maker of Oreos, America's favorite cookie, has recently changed the ingredients in response to the demand for a healthier product. No longer will we be consuming the dreaded trans fat, which has proven to contribute to coronary artery disease. The trans fat has been replaced with non-hydrogenated vegetable oil, a much more heart-friendly fat. So what is the difference between partially hydrogenated fat and unsaturated fat, and why is it important to us? We will now show the difference between these fats and why the delicious Oreo has been modified for us to enjoy.
So what are triglycerides? Triglycerides are made of 3 fatty acids with a glycerol backbone. They can either be solid at room temperature or liquid at room temperature. The solid ones have mostly saturated fatty acids, and the liquid ones have mostly unsaturated fatty acids. This is an example of an unsaturated triglyceride. As you can see, it has 4 double bonds. We are going to treat it with 4 H2s and platinum at a very high heat to convert it to all single bonds. So in this reaction, we end up with a product that has all single bonds and is fully hydrogenated. What's happened is it has actually removed the double bonds. So these 4 double bonds are what has been removed by the 4 hydrogen and the platinum. What you just saw was the reaction in catalytic hydrogenation. Here we have the same unsaturated triglyceride. In this case, we're going to limit the amount of H2 that we use so that our end product is a partially hydrogenated fat. We're going to remove this double bond and this double bond, and we'll be left with 2 double bonds in our partial hydrogenation. So in this case, we do not have all single bonds the way we do in complete hydrogenation.
When unsaturated oils are partially hydrogenated, more chemistry is happening than just the conversion of carbon-carbon double bonds into single bonds.
In partial hydrogenation, not only does it leave some of the double bonds, it also converts some of them from cis to trans. This would be cis and that would be trans.
Because there are no double bonds and saturated fats have only single bonds, they are able to interact strongly with London forces. This results in a higher melting and boiling point, which is why they are solid at room temperature. Unsaturated fats have 1 or more double bonds, resulting in weaker London forces, lowering the melting and boiling point and leaving them liquid at room temperature.
Hey honey, have you seen this article on the register about FDA and trans fats?
No.
Oh yes, it is all about trans fats and Oreo cookies.
So now you see the process involved in creating the reaction to produce catalytic hydrogenation and partial hydrogenation, and the difference between the two. Aren't we glad Oreos changed the ingredients?
O-R-E-O-C-O-O-K-I-E. O-R-E-O-C-O-O-K-I-E.